Hey guys, Mr. T here. This one is another video. This one is on the least squares regression line. So in the previous video we talked about drawing a line of best fit by eye, and obviously that is not ideal. It's not really mathematical, and everyone's line of best fit might be different based on their positioning of the line through the mean point and counting the points above and below that line in the data. However, there's a more mathematical way of finding a line of best fit for a set of data, and that involves finding the equation of what's known as the least squares regression line. Now, the process of linear regression is fitting a straight line through a set of data, and the least squares part of this least squares regression line, the least squares method, positions the line in such a way so that it's equal, its distance from all of the data points at the same time through the data is as small as can be. So basically it's doing that line of best fit by eye process for you in the graphics calculator so that there's less room for human error. So once again, you would only do this, you would only draw this line, this least squares regression line, when r and r squared deem a linear relationship to be appropriate. So that's generally when r squared is greater than or equal to 0.7. And the equation of this least squares regression line, you can find that in the same place as r and r squared. Under pressing the stat button, press right, go to the calculation tab, and then selecting for linreg ax plus b. So that for linreg function, I've never explained that before, but that linreg function is finding the least squares regression line in this form, y is equal to ax plus b. That's why it's got ax plus b in brackets. The function itself tells you what a and b are, along with r and r squared, which we've been using previously. It tells you what a and b are in the equation, and that allows you to write the equation of the line, the least squares regression line. Once you know the equation, you can then draw the least squares regression line in your scatter plot. Now, how do you do that? You substitute x values into the equation to plot points and draw a line between them. So remember, you'll need to substitute at least two values of x in, hopefully spread apart a bit, so that you can draw a line between 2 points. So here's an example. This is familiar. I'm just using the same example over and over with these different methods of drawing a line. Find the equation for the least squares regression line of the following data. As a result, plot the least squares regression line in a scatter plot of the data. So this is the age and the discus thrown distance from previously. So I've already got the data in, I've already drawn the scatter plot. So this new process is actually finding the equation of the least squares regression line. So how do we do that? I've entered the data in stat edit. Now I press stat, move to the right to the calc tab, scroll down to for linreg, select that, tell it where the x and y data is and calculate. And what I get looks like this. Linreg pops up. It says y is equal to ax plus b. It's just confirming that we're doing a linear equation. It says a is equal to, approximately equal to 3.2895 to 4 decimal points. It has a lot more decimal points, but I'm doing it to 4. I suggest you do the same. B is approximately equal to negative 20.3421 to 4 decimal points. R squared is 0.8414 to 4 decimal points. And r is approximately equal to 0.9173 to 4 decimal points. As before, r squared is greater than 0.7, so it's appropriate to do a line. So our equation stands at y is equal to 3.2895x plus negative 20, so it becomes a minus sign, negative 20.3421. Where did I get that from? Well, this function is telling me the line is in this form, ax plus b, and this is telling me what a is, 3.2895. X, I don't know, you leave x there. B is negative 20.3421. I tried to add it, but a plus and a minus sign become a minus. So this is the equation of the least squares regression line. Now that I've got the equation of the least squares regression line, I need to find points on it so that I can plot it. So, firstly, what I could do is substitute a point in. I'm not going to substitute 0 in because I can see already that I would have a negative 20.3421 on the y-axis, and I don't have that drawn. So I'm going to have to start somewhere else. So I'm going to start off with 10. So I'm going to plot the point when x is equal to 10. What is y going to be according to this equation? 3.2895 times by x is equal to 10. Take 20.3421. Go back into the calculator, solve this. 3.2895 times by 10 is equal to 32.895, and you're taking 20.3421. Take 20.3421. That comes to 12.5529. So therefore I have 1 point. 10, 12.5529. That's one of my points. We need to substitute something else. Let's go to the extremes of the graph. Let's go 10. So we'll do 20 this time. Y when x is equal to 20 is going to be 3.2895 times by 20. Take 20.3421. 3.2895 times by 20. Take 20.3421. That comes to 45.4479. So my other point is 20,45.4479. So I can plot these now. 10 to 12.55. So it'll be around here somewhere. Not exactly, but close enough. And then 20 to 45. 45 would be here. 45 and a bit. So around there would be my other point. So now, using mathematics this time, using the calculator to determine the equation of a line that is that makes the distance between the line and all of these data points as small as possible, we've determined this line should do. And hopefully it's pretty close to the line of best fit that I drew previously. So that's the least squares regression line. Always label it y is equal to 3.2895x. Take 20.3421, least squares regression line. And let's see if it follows the rules of a line of best fit. Or gets close to it at least. 1, 2, 3, 4, 5, 6, 7. 7 dots above. 1, 2, 3, 4, 5. 5 dots below, so not exactly. Let's see. This could be due to inaccuracy of my drawing. That point looks like it may have sat on the line. If that point was on the line, then you'd have 1, 2, 3, 4, 5, 6. 2, 3, 4, 5. You'd have an more even number. But anyway, that is the process of drawing a least squares regression line, finding the equation, then plotting that equation through your data. Hopefully that helps you out with this more mathematical method of finding a line of best fit, and I'll see you in the next video.